When I look back and I think at the UBC Building, which is now a very nice example of how composite can work, the UBC Building has implemented two types of innovations. The one innovation is a composite floor. The second innovation is composite stairs. When we look at the composite floor, we look at a way of joining two materials, joining their advantages and eliminate the disadvantages. So at the UBC Building, we have an LVL panel, and on top of that LVL panel, we have an insulating layer, and on top of that, we have a concrete panel. And the concrete and the timber is rigidly connected to the shear connectors. And that allows for a very slim floor with an outstanding performance. The wood reduces total weight by a factor of 50 at least. The concrete, on the other hand, provides a compression zone. It provides the diaphragm. It provides a fire barrier between one and the other floor. And it provides the mass you need in order to put the floor heating in. The second innovation is the staircase. And the staircase is a revolution, the way it has been built, because it is a moment rigid connection of a very flat glue lamp cross-section. The real revolution in the timber building industry we have through the plates. And the plates is a CLT plate. You can use it in a wall, in a floor, in a roof. It creates diaphragm, it creates bending capabilities. So the plate was combined with a stick, the revolution. So what we do with the connection is we have a finger joint, but the jointing of the fingers is not made out of timber, but it's made out of steel. We glue in plates, and therefore we glue in a material that has a plastic performance. And the first tests are, of course, static tests. We call them push-out tests. You have a picture there where you have a push-out test of a concrete layer, a timber layer, and you push them against each other. And you see how stiff is that intersurface. The next way would be a dynamic test. You don't push it to the yielding, you push it 1 million times, you push it 5 million times, you push it 10 million times. What happens? That's another test. It gives you more answers. The bending test is the next step. You actually go from a little specimen into a building component. There's also thermal testing. You have to test it under fire conditions. All those testing on the composite system I just explained had the final result that the weakest element in the composite cross-section is a steel. We had that on the static test, and we had that at the fatigue testing conditions. So therefore, the steel is the weakest point, and the steel is a material we know most and we can control most. And therefore, we feel most comfortable with the composite system. We think the steel as a moderator between concrete and timber is a very smart way of doing things. The composite approach allows everybody involved in buildings to do new magic that has not been done before. And that's the real beauty behind it. It's beneficial for the concrete guys, for the steel, for the user, for the contractor. It can be a very beneficial tool for anybody involved in the building system.